Hi everyone, this is Ajeet Singh Raina, and today I bring you an exciting topic around rise of Cube Tools recommender system. So let's get started with it. A little about myself. I'm maintainer of KRS project, which is Cube Tools recommender system, which I'm going to talk about. I'm working as a developer advocate at Docker. I joined Docker around 2 years ago. I'm author at collabnix.com. This is my community site with over 10,000 plus people who have been contributing number of blogs to this particular website. I'm also ex-Docker captain and community leader. I have been part of the ARM community and been honored as distinguished ARM ambassador. In the past, I have worked in the company like Dell EMC for almost 8 years, VMware, Redis, and CGI. Now, before we jump into the KRS tool, let's talk about the problem statement. Now, it has found that 60% of the DevOps engineers spend more than around 10 hours per week in search of optimized Kubernetes tool. And that is the reason, if you look at the CNCF landscape, that is increasing massively. Under each of these categories like observability, machine learning, there are so many tools. And that brings a confusion, right? Which tool to choose for your infrastructure. And it has been found that 40% of DevOps have used the wrong Kubernetes tool for their needs. Like I have faced a similar kind of a problem where I have been building or troubleshooting few of the in-house Kubernetes cluster, and then I found that after 4 months there is already a tool which has been introduced. Right now, this is a survey which was organized by Cast.ai, and they have seen that Kubernetes tooling is the major problem today. Now, we have been also seeing that at one point of time there is a problem which is it is an ongoing problem. The other way around is cloud native AI system is again trying to solve the same problem which DevOps has, but it is more like how you can use AI to improve the cloud native system. And what we have done, we have taken both of the concept together and build a kind of a product called as the Cube Tools recommender system. Now, when we talk about AI, there are a couple of tools which are available in the market, right? We have a Copilot, KRS, GPT, which solves the problem, but these tool doesn't help you with the tooling stuff, right? They don't give you the recommendation around the tooling. They help you in the debugging the cluster, which is one part of it, but tooling has been a main kind of a lot of people are facing a lot of issues around it, especially the DevOps or SRE engineers. So we introduced a new tool called as the KRS, which is Cube Tools Recommender System. It is a future of Kubernetes tools discovery. Now, what is KRS? KRS is a GenAI powered Cube Tools Recommender System, which means that it is intelligent enough to scan your existing Kubernetes cluster. It can detect the tools from your cluster automatically and generate some kind of a recommendation. It also provides you with the health check. It also enables you to export the pods information. At this point of time, we are more targeting on the pod. And in terms of health check, we are also using an AI LLM tools like models like OpenAI as well as the Hugging Face, which we can use, right? So this is a robust tool which we have been working on. And to start with, if you are a CLI fan, you will definitely love it, because you start with some kind of an initialization, say KRS in it, you scan it with KRS scan, recommend, and health. So these are the CLI implementation which we have. Now, when you do a KRS recommend, what it is doing, it is trying to go ahead and create a kind of a JSON file and give you all those categories and try to recommend you with the best tools which are available. Say if you might be using some kind of a random tools which might not be solving your problem, right? So we come up with some kind of a recommendation, and this recommendation is done based on the popularity around all sort of leading forums, just like a Stack Overflow, LinkedIn, Twitter, and based on the experience which this DevOps and the SRE engineers brings on the table. Now, we have tested this particular tool for multiple environments like Amazon EKS, we have a Minikube, Docker Desktop, Google Kubernetes Engine, as well as the kind. So to show you a quick demo, I can go ahead and let me Cube Tools KRS. So you can just go to this particular repo here, and you have already seen that this is something which we open source a few weeks back, and you have all this information about how to get started with this particular tool. Now, as a prerequisite, what you need to do, you just have to have a Kubernetes cluster running with a specific version of Python. We do have a plan of having some kind of a container image or in the form of a, say, Docker desktop extension. So we have tested all those environments which you can see here. All you need to do is clone this repo, do the pip install, and you have a KRS already up and running. You can see these command line options here, which shows you about how to initialize it. When you run a KRS init, which means that you are trying to initialize and load the scanner, you scan your cluster, and once you scan this cluster, you will see that there are a list of tools. So at this point of time, you don't have any other tool which is installed. So let's say you have some kind of a sample Kubernetes tool which you have installed. We have provided with some kind of a script here. But assuming that you have already tool installed it, so when you do a KRS scan, it basically lists that the available tools. Then you do a KRS recommend, and it try to find out those tools names and corresponding CNCF status, if these tools are available in the CNCF or not. We also provide you the KRS health, which checks the health of your Kubernetes cluster, which is really important. And when you do a KRS health, you have certain commands like KRS pod. You can specify the namespace, as well as you can also choose the model provider. So here in the example, we have a model provider for health check, which is an OpenAI or Hugging Face. You pass the OpenAI key and try to specify the namespace, do the KRS health, and it gives you all the information about what's wrong with your cluster, right? So those kind of stuff which you can do. And in this example, you can see here, you can even specify the pod in the namespace, check the logs, right? And even if you want to use the Hugging Face, you can go ahead and choose the Hugging Face if you have a local model which you have downloaded from the Hugging Face altogether, right? Now to show you a quick demo, what I'm going to do here is try to see if we can showcase in terms of Killer Coda. So we have set up a few of the environment for you, which would be easy, right? So if you go to the Killer Coda and start this KRS scenario, in this we will clone a KRS repo, try to install KRS locally, initialize the KRS, right? So let's start this. So once you have enabled it, you see a lot of steps on the left hand side. Just go ahead and try to copy these steps, or you can just click on it, and this is, I prefer going ahead and typing it. So once you clone this, you have the whole repo which is right here. I can go ahead and install the KRS. Now once you install this KRS locally, all you need to do is try to do a pip install, and it should install your KRS locally on this machine. So let's wait for some time. Till the time, I will just copy this pip install here, and it should not take much time. So I will go ahead and say pip install dot, and it will install all those binaries and libraries which you require for KRS. I can clear the screen and say KRS help, and now my KRS is up and running. There are a couple of commands here: export, health, init. So the first command which I'm going to do here is KRS init, and it will initialize my tool. It will download all those libraries and binaries which you need to do. Now, assuming that there is no Kubernetes tool which is installed, I can quickly run these sets of command to set up, say, the first one is more like, if I want to install KubeView, how it is going to look like. I will be using Helm here to install KubeView. KubeView is more like a UI interface, which allows you to see, the pods in the browser. And the next one which I am going to pick up here is more like a Grafana monitoring. So I picked up two of this particular tools. I can quickly go ahead and scan it. Let's see if it has already installed it, but definitely it will list out all the tools which have already been installed. So for time being, you can just ignore this error message. But if you look at these tools and the CNCF status, it is just listed. So if you look at Grafana, Grafana is listed as under the CNCF as well. It says like this is a rank 1, which means that it is the most popular observability stack which you have, right? And if I go ahead and try to come up with some kind of a recommendation, okay, what is the recommendation which is coming from the KRS? Like it says like in terms of different categories, like the observability tool, we have a tool called there are certain tools which are in the incubating stage or the unlisted. So Grafana is already the best which you have been using. But if you look at the other categories like cluster management, we have a Rancher which has been recommended. We have a Cilium as a network policies. Like so, KRS helps you with some kind of a recommendation. I can even go ahead and do a kind of an export to export the pod information. So I can quickly do this, and it gets stored in a kind of a JSON file here, right? And this is an exported JSON file which you can rightly see here. Now, how about debugging stuff, right? How to fix the detected issue? So I can use KRS Health here. It gives me the information about, okay, if I have to choose an OpenAI, how it is going to it is just going to go ahead and install the OpenAI. It might ask you for the OpenAI key if required, but right now I will just go ahead and try to see if I can use an OpenAI. So let me see if I can download it one with an OpenAI key, right? So let me pick up this one, or you need to create a new API key here. I can specify the model name, which is as a GPT 3.5, and once I do this, if my OpenAI key and the GPT is correct, then most probably it should. So let me look at the OpenAI keys here and create a new key. So I can create a secret key for KRS, and this will help me to copy this key, put it. So I can run KRS Health, ask me of the OpenAI key, pass the key, the model name as GPT 3.5 have hyphen turbo, and this will try to create a kind of a namespace in the cluster. So say if I select 4, right, so the pod in this namespace are more like something like this. So if I click on say 8, selecting the kube controller manager, and try to see if there is any issue with it. So it starts the interactive session. There has been logs and events, and it says like these are the logs which has a lot of warning. I can say suggest a fix for 3, right, which is an error message. So it start going through all those error messages and giving you some kind of a recommendation, say like, okay, verify the airbag permissions, or cluster role or binding, or apply the airbag changes, right? And then I can always go ahead and end the chat like this. So this is a quick demo around how the KRS works. I would recommend you to visit this GitHub repo and try to see how you can you can contribute to this website. A few information here is especially the KRS is you can go to the repo and just help you suggest. Thank you.